Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Prescind by Nicholas Duhale, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. The grid is covered in fog. Placing a correct digit will clear the fog from that cell and potentially from other cells somewhere in the grid. No guessing is required. So this is dynamic fog of war. Digits separated by a V sum to 5. And digits separated by an X sum to 10. Not all V's and X's are given. So as an example, oops, we don't have the pen tool here. We also need a letter tool. So say that we had the blue X is basically a V. So say we had a V here. Think of it as a hypothetical. Then if we had, say, a 4 here, this would have to be 1 because these digits would be separated by a V and therefore must add up to 5. And say we had a 3 here. This would then have to be 7 because these two digits must add up to 10 because there's an X in between them. And that's an example of how V's and X's work. Along a green line, adjacent digits differ by at least 5. So, for example, this is commonly known as German whisper lines, but I call them whisper 5 lines because the setter came up with a great naming for this, and which is very easily extendable. So that's why I use that. So as an example, say we had a 3 here. This would have to be 8 or 9 because the only digits which are 5 or more away from 3 are 8 and 9. So that's how these whisper 5 lines work. We have box borders divide each blue line into segments with the same sum. So the sum of these two digits must equal the sum of these 3 digits here. So that means that these two digits must equal the sum of these 3. And these are otherwise known as region sum lines. And finally, we have along pink lines, digits form a consecutive sequence in any order. So say we had like a pink line here. Oops, say we had a pink line this way. I don't know. Oh, I bit the wrong one. Say we had a pink line this way. Then these 4 digits would have to basically form a set of consecutive sequence. And you could have something like, say, 7, 9, not 5, 8, and 6. And this would be a valid, and these are known as Renban lines. This would form a valid Renban line because 6, 7, 8, 9 is a consecutive sequence. Yeah, and you cannot have repeats as a consecutive sequence, obviously, because it would be then like, say you had 7, 9, 8, 7 here instead. Well, the problem is 7, 7, 8, 9 is not a consecutive sequence, right? Because 7, 7 are the same digit. So that's not a sequence there. So it's basically 4 digits which have to be, yeah, the consecutive sequence is a pretty good way of putting it, actually. But that's an example of how these pink lines, Renban lines, work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. These digits along this whisper 5 line, first of all, you can never have 5 on a Whisper 5 line in normal Sudoku. And the reason why you know that is subtract 5 or more from 5. What do you get? You get 0 or less, which is not normal Sudoku digits. What happens if you add 5 or more to 5? You get 10 or more, which are not digits. So therefore, 5 can never be on a Whisper 5 line in normal Sudoku. So we know 5 has to be one of these two digits here, because there must be the digits 1 through 9 in a complete box. And these digits add up to the same sum as these. Well, this is going to be 10, and then another digit, which means this is 11 at minimum. So we know along this region sum line, it has to be 5 plus at least 6 to add up to the sum of these digits. So this must be 5 and a high digit here to add up to 2, and this is 10. So 5 through 9 add up to 14 at most. So this would be 10 and 4 at most. So this is 1 through 4 here. Well, on a Whisper 5 line, you'll always alternate between low digits and high digits. And the low digits being 1 through 4, the high digits being 6 through 9. And the reason why you know that is what digits can be next to a low digit. 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 only can be next to 9, all of which are high digits. Well, and what digits can be next to 6 through 9, which are the high digits? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1 through 3, and 9 can be next to 1 through 4, all of which are low digits. So you'll always alternate between low digits and high digits on a Whisper 5 line. What happens if we try to have a high digit here? Then this becomes high, low, high, low, high, low, high, and we'd have 4 high digits on this Whisper 5 line, but we need another high digit in this box for this region sum line to work. And that's 5 high digits in a single box, which is not allowed, right? Because we only have 4 high digits from the digits 1 through 9. So therefore, this cannot be high, low, high, low, high, low, high. It has to be low, high, low, high, low, high, low. Which means this must be, so these are all low, and these are all high. Well, for the high digits, all of them are between 2 unique digits on a Whisper 5 line. Well, 6 can only be next to 1 unique digit on a Whisper 5 line, so 6 cannot be in any of these high spots, so it must be here, which means this must be 5 and 6 as a pair, and it must have 1 here. Because this adds up to 10, 5 and 6 adds up to 11, 11 minus 10 is 1, and that's how we know that. This is a Renban line, which means it's 7 digits consecutive. So it has to be 1 through 7, 2 through 8, or 3 through 9. Well, if we had this be 3 through 9, this has to add up to 5, and it cannot have a 1 in it. So this must be a 2-3 pair here. That means this can't be 1, 9, 2, 8, or 3, 7. So this has to be 4 and 6. This cannot be 6 here because of the 5, 6 pair in the row. So this is 4 and that's 6. These are low. These are low. Remaining digits in this upper central box are 5, 7, 8, 9. Obviously, 5 cannot be here because of the 5, 6 pair in the row. So this has to be a high digit here. Well, this is adding up to at least 10. So it cannot be 1 and 2 here, because 1 and 2 only add up to 3, right? So if this were 3 through 9, this would be 1 and 2, but that's not possible. So this has to be either 1 through 7. Actually, can it ever... If this is 1 through 7, that would force this to be 8 and 9, which adds up to 17, but 17 minus 5 would have to have a digit adding up to 12, which is obviously not possible. So therefore, this must be 2 through 8 on the Ren band, and this must be 1, 9 as a pair here to add up to 10. So 2 and 3 makes this a 5. That eliminates 5 here, 5 here. This becomes 7, 8, and 9. That's a triplet. This 1, 9 pair eliminates 1 and 9 here, so it's 7 and 8. Therefore, we have 5, 6, and 1, 9 accounted for. This cannot be 6 or 9 as a high digit because of the 5, 6, and 1, 9 pairs in the row. So this is 7, 8, which forms a 7, 8 pair. So that forces this to be 2 or 3 here. Okay. So we have something similar here in this lower left-hand box as we did to the upper left-hand box. So 5 has to be one of these two, but 5 with another normal Sudoku digit never adds up to 5. So therefore, this must be 5 here, which makes this 6, which makes that 5 there. So this is a high digit. This is not a high digit. It's 5. These two digits must add up to 5 here. So they're both low, and this must be 1 or 4. But similar to the way that we figured out these cells, if we try to have low, high, low, high, low, high, low, that would require in this box 4 lows already on the Whisper 5 line, plus a 5th low here, which is not allowed. Because if it were, well, it's just not allowed because, yeah, there are only 4 low digits. So this must then be high, low, high, low, high, low, high. So these are all high, and these are all low. The low digits on the Whisper 5 line are each next to 2 unique digits on the Whisper 5 line. Therefore, they cannot be 4. Whereas the 4 in that box, it must be here. So this is 4, which makes this a 1. Therefore, these add up to 9 here. So it's either 2, 6, or 3, 5, adding up to the 1. This can't be 5, so this can't be 3 here. These are low. This is middle. We have a Ren band here. We also know this cannot be 1 and 9 here, because that would eliminate all possibilities for that cell there. So what are the possibilities here? 2, 8, 3, 7, or 4, 6. The thing is, though, for 4-length Ren band, or sorry, 7-length Ren band, it must be either 1 through 7, 2 through 1 through 7, 2 through 8, or 3 through 9, which requires that on the Ren band, they have to have 3 through 7 on the Ren band. So this cannot be 3 through 7, which makes this 2 and 8. So this is 2, 8 as a pair, adding up to 10. Therefore, on this Ren band, you cannot, one of these is 2 and 8, the other one has to be 1 or 9. And if this were 1 and 2, the problem is that doesn't work. Right? So if this is 3 through 9, we have 1 and 2 here. Therefore, these 3 digits must add up to 3, which obviously can't work because you can't have 3 unique digits adding up to 3. So this must be 8 and 9 here. And then this must add up to 15. Or sorry, 17. 2 here, but these 2 digits must add up to 15. To make this region sum line work. Because if this is 8, it can't have a 1 here, because then 2 through 7 and then 9 is not a consecutive sequence. So therefore, this must be 8 and 9. And same thing with 2 and 9 here. 2 and 9 forces 1, 3, 4, 5, 6, 7, 8, which is not a consecutive sequence. So this is 8 and 9. This is 2, which forces this to be 1, 3, and 5. Add up to 9 because of 2 in the row. This has to then be 6 through 9 here, and 6 through 9 here, to add up to 17. So this is low. We have low here. This is a 5. These are high digits. So 9 eliminates 9 here, so that's 1 and 9 there. 8 cannot be either of these digits, so 8 has to be one of these two. This is low and is 2 or 3. 4 cannot be here, so and cannot be 1 through 5 there, so this must be a high digit. And it's 7 through 9 there, then. So 4 has to be one of these two digits here. This is a low, obviously. These are both high. This is high. One of these is a 4, which means one of these is a 9 to correspondingly go with it. Okay. That means where is the 4 in column 1? It must be one of these two digits. 6 has to be one of these two digits here because it's next to only one unique digit on a Whisper 5 line, which is 1. So 1 has to be one of those two. We have a low and a high digit here. We have a low and a high digit here because of what's left in column 1 and 2. Therefore, these must both be high digits left in column 3. So this can't be 3 or 4, so it must be 1 or 2 here. This can't be 1, so this has to be 2 or 4 here. And this could be 1, 2, or 4 there. Okay. So 3 has to be one of these two. So since this is one of these two is guaranteed to be 3, this has to be 8 or 9. We have 7, 8, or 9 here, 7, 8, or 9 here. Oh, where's 3 in this upper left-hand box? Can't be here. It has to be one of these two, which eliminates 3 from being there. Therefore, where's 3 in this lower left-hand box? It has to be here. So this is 3, which is next to 8 and 9, which forces this to be a 6, 7 pair here. This is 1, 2 as a pair. Okay. Interesting. Remaining digits of column 5 are 1 through 6. Obviously, no 1, 2, 3, or 5 here. No 1 or 2 here because of the 1, 2 pair in the row. No 4 here, because, or 4 or 6 here because of 4 and the 6, 7 pair in the row. No 3 here because of 3 in the row. Remaining digits of column 6 are 1, 4, 6, 7, 8, 9. Obviously, no 1 here. No 4, 6, 7, or 8 here. No 9 and 1 here. And no 8 or 9 here because of 8, 9 pairs, 1, 2 pairs, 6, 7 pairs, and 8s and 9s in the rows. Okay. We could do something similar in column 4. So we have 2, 3, 5, 7, 8, 9. No 7 or 8 here. No 2, 5, or 9 here. And no 3, 8, 9 here. Okay. Remaining digits in column 2 have to be 2 with a 7, 8, or 9 here. And this is 4 with 6, 7, 8, 9. Okay. We know 3 is one of these two. So 7 can never be next to a 3. So therefore, this must be 8. So that's 8, which forces this to be 9, which forces that to be 8. Therefore, this cannot be 8 here. This becomes a 7, 9 pair, which eliminates 7 and 9 in the rest of the column. So this cannot be 7 or 9. It's 2 and 8. That eliminates 2 and 8 in the rest of the box. And this can't be 8 or 9. So this is 4 with 6 or 7. We have 2 or 3 here. 1, 2, or 3 here. This digit cannot be next to, has to be next to 2 or 2 and 3 at least, which means it cannot be 7. So this must be 9 here. That must be 7 here. 8 eliminates 8 here, so it's 7. This can't be 7 or 9. It's 8, which forces this to be 9 there. 9 has to be next, 4 cannot be next to a 7. Neither can 3, so this becomes a 1, 2 pair here, which eliminates 1 and 2 in the rest of the row and box. This can't be 2, it's 3. This can't be 2, it's 4. 1 and 2 eliminate 2 here, so that's 3, which makes this 2, which makes that 3. So this is 7, 8, 9, which must be next to a low digit on a Whisper 5 line. So this cannot be 5 or 9, it's 2 or 3 there. Remaining digits of row 1, we have 4, 5, and 8. Remaining, it can't be 8 because of 8 in the column. Remaining digits of row 3, we have 2, 6, 7. And this can't be 2 because of 2 in the column. This is on a Renban with this cell at least. We don't know what that is. This must be 2 high digits, so we have to have a 9 here, and then it's either 6 or 7. Okay. What else do we have? Hmm. Hmm. 3 cannot be here, 3 cannot be here in this lower right-hand box, so where is 3? 3 has to be one of these two. Remaining digits of row 8 are 3, 4, 6, 7, and we cannot have 8 here because of 8 in the box. Oh, this can't be 5 because of 5 in the row. This can't be 3 because of 3 in the column. So where is 3 in column 8? Cannot be here because of 3 in the row. Can't be here because of 3 in the box, so it has to be one of these two. So we have a guaranteed 3 here. Remaining digits in row or column 8 are 3, 4, 5, 6, 7. And obviously 3 cannot be there. Remaining digits of row 7. We have 1, 2, 3, 5, and that's it. Okay, so where is 9 then? In row 7, 9 has to be here. So this is 9, and this is a 2-length Renban, so it must be 8 and 9 here. So that's 8. These are both high, which eliminates 8 and 9 in the rest of the column. Also, where this can't be 7 and 8, because it must add up to 15. So it must be 6 and 9. 9 eliminates 9 here, so that's 6, that's 9. This cannot be 6 anymore, it's 4. This can't be 6 or 9 or 8, so this is 7, which must be next to a 2 on a Whisper 5 line instead of a 3. So that's 2. This is 4. It must have a 1 or 3 here. So 2 eliminates 2 here. 4 eliminates 4 in the rest of the column. 7 eliminates 2 and 7 can't be here. 8 can't be here because of 8 in the box. No 7 here because of 7 in the box. No 7 here. This can't be 2 or 7. It must be 5, which eliminates 5 in the rest of the column. So this becomes a 3-9 pair. That eliminates 3 and 9 in the rest of the column. So this can't be 3. This is 8. This must add up to 4. And you can only have 2 unique digits adding up to another unique digit. Because you can't have 3, because 3 unique digits would never add up to 4. So this has to be 1 and 3, because you can't have a 4 here. And you have to have a 1 on somewhat one of these parts. It's either here, here, or here, here. So it's probably going to be here and here. So this must be 1 and 3. That means this can't be 3 here. Whereas 3 in row 7, it can only be here. So this is 3, this is 5. No 1s here. This can't be 2 or 5. That makes this a 6. So that leaves this as a 2-5 pair here. 4 eliminates 4 here. So this is 1, 6 as a pair, which eliminates 1, 6, and 1 in the rest of the column. This has to be 6 in one of these two cells. So this can't be 6 here, and it cannot be 5. We have a 4, 6, 7 triplet in this lower right-hand box, which eliminates 4, 6, and 7 in the rest of the box. So this is 1 and 2 as a pair. This cannot have a 6 because of the 6 in the box. Six eliminates 6 here. 9, 9. 6 eliminates 6 here. So where is the 6 in row 8? It must be here. So this is 6. This is 4, 7 as a pair. 6 eliminates 6 here. So where is the 6 in row 3? It must be here. So that's 6. This region sum adds up to the same as this. So this must be 15 or 16 here. So this adds up to 15 or 16 here. Can we have a 3 here? 3 plus 5 plus 6 at most adds up to only 14. So the answer is no, this cannot be a 3. Therefore, this is 9. That's 3, which eliminates 9 here, which forces this to be a 9 here. So this 3 eliminates 3 here. Where's the 3 in column 8? It has to be here, so that's a 3. This adds up to, so these two add up to that digit. So it's either 1 and 5, or it can it ever have a 2 here? The answer is no. So 2 and 6 adds up to 8, which does not add up to this digit here, because these are both 9. These must add up to that. So this has to be 1, 5, and 6. So we have 1, 5, and 6 to add up to, because you can't have 2 here, because 2 and 1 add up to 3, which can't be there, and 2 and 6 add up to 8, which can't be there. So 1 and 5 then must add, it can't be 5 and 7, obviously adding up to 12, so it's 5 and 1. So this is 6, that's 2. That makes this 6, So this is 7, which makes this 6. 6 can only be next to 1 on a Whisper 5 line. So this is 1 and 2, which makes this 1 and 2. So there's no 6 here. 2 eliminates 2 here. So that's 8, which makes that 2. I don't know why that cleared that cell there. We kind of knew that that was going to be there. Oh, it does. Okay, that's helpful because we know that this must be the sum for the region sum line. So this cannot be 6 and 9 to add up to 15 because we already have a 6, 9 in the box. So this must be 7 and 8, which means this can't be 8 here. So this is 7, that's 8, which eliminates 7 here. So it's 2 and 7. 7 eliminates 7 here, so it's 4, which makes this 7. 4 eliminates 4 here, so it's 7 and 4. This can't be 7 here. 7 eliminates 7 here, so that's 4 and 7. 4 eliminates 4 here, so it's 5, which eliminates 5 here, so that's 4. 2 eliminates 2 here, so it's 1 and 2. This can't be 4 or 8, it's 5. This can't be 4 or 5, it's 8. That leaves the remaining digits as 4 and 1. And that's how you solve it. Yeah, interesting. Pretty straightforward about the logic. The execution isn't too bad. And it flowed very well throughout. So it was a very nice, like, following the path of the Fog of War. Yeah, overall, just a very, very nicely set puzzle. I guess, yeah, we did have to have that information for this, right? So that clearing there was pretty helpful. Yeah, very nicely set puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.